I couldn't have asked for a better intro. Thank you so much. It was actually at WWDC that I met Larry in Heroku's basement. We were doing a meetup for Cocoa Pods, and I don't know if he was joking, but he was like, "Oh, you should come out and talk in one of these things." So here I am, straight from San Francisco, and it's wonderful to be here. Thank you so much. This is what I learned from AF Networking's GitHub issues, which is the really enlightening kind of presentation as compared to the depressing one of what I learned from Stack Overflow and the questions that come up on there. You'd be surprised. Heroku. I work at Heroku, where I actually make a lot of Mac applications at the moment. Those are two with really beautiful icons. We have Induction, which is a polyglot database client, and on the right there is Postgres app, which is a really easy way to install Postgres on the Mac. And that's the last I'll say about Heroku, because today we're talking about AF networking. And if we're going to talk about AF networking in any comprehensive way, we have to talk about GitHub. GitHub was absolutely responsible for getting all the momentum around this project, or all the collaboration, and it just worked wonders. I think GitHub and GitHub issues and pull requests and all of that kind of represent a neoclassical notion. It gets back to the Greek forum, if you will. It was a place where you could discuss, heady ideals and, I don't know, argue and have the force of debate power your arguments, and I don't know, it was a really cool thing going on there. If you want, you can poison yourself with hemlock by, I don't know, arguing too passionately, but it's a good place, and a lot of good things come out of that. And here are some of the lessons I learned over the last year and a couple months that AF Networking's been out. And lesson one, as Larry kind of alluded to earlier, is designing great software. I'm not assuming AF Networking's great or anything, but I think to get towards great software, it means saying no, and it means saying no a lot. Every line of code needs to justify its own existence. Rather than think of building software as a constructive process, like something that you're building up block by block, I'd say that first part is just making it work. Make it work, just build it up, and then the rest of it, kind of the fine art of software engineering and design, is chiseling away at that until it's the smallest possible thing it can possibly be. And that's where all the attention comes from. So every feature adds complexity. Complexity is going to be something that, if you're designing a framework, it's going to be the enemy. It's going to be one more potential thing that users are going to be confused about, and it's just going to make for a worse experience. Just to give you an idea of like some kind of hard decisions and things I had to say no about recently. We had ordered query string parameters. Somebody was asking about, there's one Windows server that needs to have parameters in a specific order, and to incorporate that, I would have to change one of the parameters in it was supposed to take a dictionary, and there's no native ordered dictionary in Objective-C, so I had to say no to that. Customizing query string formats, so arrays. Right now we're using Rails formats where we have subscripting within square brackets. So you say, array, open square bracket, close, equals, and then you just do that to create an array. I don't know. That seems like a pretty good default. And again, these are things that you can override. Again, things overriding like properties for delete parameters. I don't know. Apparently those can be in message bodies. It makes sense to send those. Retrying parameters, like how many times to retry an operation, but that was too difficult to kind of munge out across all the general use case. Options to parse like true and null as JSON objects, instead of dictionaries or something like that. These are all things that, like, implementation-wise, they were pretty easy things to say no to because they would have increased the complexity. I will say, just a side note, if you're doing Arc, please just commit to Arc. Don't do macros so you can do Arc and non-Arc stuff. That's sort of a weird side note for all you actual iOS developers out there. So, kind of a corollary to that, if you can't give them what they want, give them something better. There's that old quote about if you'd ask people what they wanted, back in the turn of the century, they would have said a faster horse, not an automobile. So kind of take every feature request that you get, everything that somebody wants to add into your code, take that as just a data point, as a larger picture, to paint the larger picture of what your library needs, what you can add, what should be improved. So you don't necessarily give them exactly what they want. You just kind of, it's up to you, as somebody who knows the code better than anybody, to take those requests and to intelligently and responsibly merge that in. So a good example of this was custom mime types. In AF networking, there's a notion of success and failure of a request which is dependent on whether you got what you asked for from the server. So let's say you have a JSON operation. It's going to give you JSON at the end. You're expecting application JSON from the server. And that was a good default. You had, these two. These are relatively sane defaults. Application JSON is the official MIME type. And then JavaScript, if it's JSON P, some other people encode it that way. And that just makes sense as a default for what is JSON and what should be considered successful. But then somebody mentioned that Facebook uses text JavaScript for some reason. So we had to add that in. So that was one of those hard-coded, acceptable data types, MIME types. And then, I don't know, there's a whole list of other kind of esoteric ones that kept on popping up. And at that point, where you're just like, I want to be prescriptive, I want to be correct, I want to actually encode real behavior rather than be just a grab bag of different standards. I'm trying to be, I don't know, correct about what I'm programming. That was one of those things you could almost easily just close and get on with life. But kind of looking at all those feature requests, I realized that actually the AF networking had a huge flaw in it, in that there's a very good case for one-offs, and that is actually back to GitHub itself. Application, they send their JSON as application vendor GitHub plus JSON. So as hypermedia kind of takes off in this new brave new direction of custom media types instead of like versioning your API and the URL or something like that, this became like a real use case that we absolutely had to incorporate. So that forced the adoption of a much better solution in general, which is now, as a class method, you can add an acceptable content type, and then all requests will be able to accept that. So you don't have to subclass and do any sort of nonsense there, or like manually monkey patch the code. You can just do that, and it'll incorporate anything that you really need. So it went from kind of this slippery slope of decreasing standards and incorporating things that were just kind of incorrect to a real feature that addressed real problems. And kind of on that JSON train, let me talk about JSON libraries. There are a bunch of them. And the reason for that is that Apple took a really, really long time to actually get their own native JSON parsing. That was a point of pain for me. Everybody, I mean, you look down this list, I think a lot of people are probably JSON-Kit fans, or maybe SB-JSON. I don't know, if you guys want to be really hipsters, Nextive-JSON is, it says in the documentation it's slower than it, but some people, like, it's slower than JSON-Kit and all those others, and people still use it. I don't know why. But I don't know, it's sort of like a religious thing. To me, it's sort of a, meh, I don't care. It's JSON. It's JSON parsing. It's not going to be a really important part of your application. So anytime somebody mentioned that, or they were trying to add their own favorite pet JSON thing, and they're asking for support for that, I really couldn't care. But instead, so the way that I kind of address that is I just put it into this thing called AF JSON utilities, and we have an encode and decode function, and this is what it looks like. It's not pretty. This is the ugliest part of AF networking. You see, in order to actually, because all these JSON libraries have different methods and take different things, some of them take strings, some of them take data, I had to create this monstrosity of a method that does NS invocation and manually calling things. It's a mess. Yeah, that's awful. And you see two other cool things. You have ifdef AF networking prefer NS JSON serialization. That's in case you have a JSON library that you don't want and you want the native one. It's a great feature. And we have a goto statement. Check that out.
Cool.
That thing is, fortunately, because of NS JSON serialization, it's going to be gone. That whole chunk of code, I'm ripping that out for 1.0. So iOS 5.0, the 1.0 targets iOS 5 and macOS 10.7 and up. So I actually get rid of a lot of stuff I didn't want. So I don't know, there's probably a meta lesson in there somewhere. ASI network queue. So kind of another sidetrack. So how many people used ASI back in the day? That is ASI HTTP requests. Okay, that's less people than I would have guessed. Back in the day, that was the workhorse. Everybody used that. It was the granddaddy of all networking libraries. I used it for my first project for SmartFM, which is a language learning startup. That was 3 years ago. It's kind of a mess. It has its edges, but it was designed a long time ago before we had a lot of the cool stuff that I get to take advantage of in AF networking, like blocks or NS URL connection. Really cool stuff. So all credit to him for kind of leading the way on that. And it still is more featured than most networking libraries, and it took a while for me to get feature parity with that. So people kept on asking for things like ASI network queue, which had features like batching and stuff like that. So instead of kind of subclassing NS operation queue, my solution was to instead have this thing on AF HTTP client where you can queue batches of operations and then get callbacks as each individual one completes, and then one for when the whole batch completes. So rather than kind of translating the design of one networking library to another when incorporating features, I was giving them something better by kind of intelligently integrating into what we already had with the architecture. Lesson 3 is an important one. Never merge in code that you do not understand. I will emphasize this. Never do this. Never. It'll hurt you in the end. It will hurt others, actually, too. This is actually one of the sadder parts of, I don't know. I still feel bad about this. So dispatch group, there was a thing, back to that method, in queue batch of operations. It has this interesting bug that because, well, actually, I have a nice illustration of this. So here's the animation. We have a queue, well, let's say we have a batch of 5 operations, right? And they're all going to take a different amount of time. And as they go, we're going to say that's completed, or that's finished, and then when it goes dark black, it's going, that's when the completion block finishes. So now that they're all gray, that means that each operation was finished. But you'll notice that it took a while for the completion blocks to finish as compared to the batch, which is just looking for all the operations to be finished. There's a difference between finished and then having the completion block finish. There's actually no way to tell whether or not that completion block on an operation finished. That's kind of in the weeds of implementation details, so sorry for anybody not so savvy with NS operation. But that's the gist, that you have this race condition, and that's a difficult thing. So a great couple friends, okay, actually back. A great couple of friends at Mutual Mobile in Austin, they came to me with this patch, and they had the solution to use dispatch group, which is this Grand Central dispatch method that would actually solve a lot of this problem. And I was all too happy to merge it in. I didn't read it close enough, and I realized that it compromised a lot of the design integrity. You had a property on on the lowest level things. That was the only way to actually make this work. So I merged it in, and I had to rip it out, and I don't know, I still feel really bad about that because now people think that it works one way and it doesn't, and you know, I let them down as an author. So that's an important thing to really just take responsibility of all that code and make sure you really look those things over. Onto thread safety, which is, you know, a challenge. It's one of the hardest things in programming, and to illustrate that, here is a screenshot of the GitHub issue. This is a beautiful issue if you want to look this up later. I think this is an animation that'll start. Let's let this go. So this guy, John Zhang, he actually is the person who made JSON Kit, and he's a great systems level guy, makes things really, really fast. So it was great to have this this patch in here. As you can see, it got really long. This conversation, that was me responding for the first time. This guy, Zach Bolin, came in and he had some ideas. And then it kind of turned into an internet argument. Yeah. So there were a lot of kind of things going on there, and he says, well, I think we should be rational. That's a kind of important point. He had to make this own demo, and he's like showing how this one race condition happened, and like he was proving that there was a leak in there, it wasn't safe, and it was like, well, I can't, what? I don't know. Seriously, this thing is a novel, this issue, and I'm so thankful for all this discussion, but I couldn't.
So who called him a Nazi first?
I stopped it. That's me stopping it before Godwin's law is invoked. Read through that. It's amazing. That could be its own, again, like mini-series on HBO or something. So it's going to kind of dovetail into lesson 4, which is don't settle for not understanding something, though. Don't merge in code that you don't understand, but don't let that stop you from actually getting some really good ideas out of things that you don't necessarily understand at first blush. Because this whole process, the whole purpose of this is to collaborate and to learn something. And what better way to learn something is from the example of other people. So back to that thread safety, what I ended up doing, and just looking through it, I figured out exactly what was going on. He had a lot of like OS and kernel level locking going on, and he was locking on integers and stuff like that. And I figured out that there was probably an easier way to just use, like, again, taking it up to the level of what AF networking is used to, the object level. So I had an NS recursive lock. And that was, it was a solution that worked well enough, and I was happy with that solution. Because the trade-off is, if I would have merged that first one in, that would have been potentially the death of the project. if I merge in code that I don't understand, and that other people, definitely other people aren't going to understand it either, I assume at least. So it's going to make people not so happy about, not interested about learning that and merging in their own code. So for the sake of the project, to keep it going, you just got to keep the code readable. Make sure that that stuff is sacred. So MVC networking. How many people have ever looked at that example project? This is a kind of obscure one. Okay, yeah, a couple of you. It's actually a really cool example project that Apple has. It was written by Quinn the Eskimo, who's kind of the person who wrote the whole networking stack. And it was actually the original basis of AF networking. All of the original networking operations, kind of the lowest level core stuff, it was all a wrapper around MVC networking. Here's the example project. It's interesting to look at least as a kind of a historical record of what was thought to be the way to do this maybe 2 or 3 years ago. Before we had blocks and before we had GCD. And here is actually issue number 8. This is really, really early into the project. This is Mike Lewis of Square, and he came with some really helpful information. He came up with this diagram showing me the wrong way to do things and the right way to do things. And initially, I was doing things wrong, completely wrong. And he showed me, he was offering a suggestion on the right way to do that. And of course, I didn't get it the first time, so he actually made a better diagram. That guy's awesome. He's a machine. So, yeah, you can kind of look through that issue if you want kind of the gritty details of it. But basically, the things I got out of that was now that we have this dispatch async pattern. So anytime that we're processing data, I realized that instead of having kind of a queue for doing network requests and a queue for doing processing on that data, I could easily simplify that using dispatch async in completion blocks on that operation. So we have a very simple architecture where instead of having to assume that processing is part of the operation itself, it's just sort of an after effect, and the data kind of lives in the operation itself. So that insight early on really guided the AF networking into the right path. I don't know where it would have been without that early feedback. The dedicated network thread was also very important. In order for this thing to actually be performant and not lock up the system, it had to have its own thread, which is something that I'm more of a graphics-oriented person. I don't. I only took a couple of years of CS. Like, I didn't get into the hardcore stuff that would actually make me qualified to write anything that you would trust with networking code. But okay, that's the thing. It's not so much the individual. It's just if somebody's willing to learn and somebody's willing to incorporate knowledge from others, that's where the strength of the project comes from. And as I said, custom dispatch queues for background processing. Each operation has its own custom queue. Again, implementation details. This is one of my favorite threads. It was called, very ominously, the deallocation problem, which is a thing that Apple refers to. Here's the original thread. This is Adam Ernst, who worked on Turntable, and he's talking about this deallocation problem. And basically, it's this, and I hate to read text off a slide, but it's kind of complicated. When you start a secondary thread, or when you're doing multi-threaded application, it's common for you to retain the target object. So you're going to make a reference to something. So in our case, it was an operation, and it was making reference to, like, say, a UI view controller. But if you don't ensure that the thread releases the reference before the main thread releases its last reference, you're going to do dealloc on the secondary thread. And if you're doing UI stuff, it's very important that that all happens on the main thread. So that's the bad things happen. That's the deallocation problem. And I didn't even know that existed. In fact, a lot of the things that I've learned in the last year are directly from kind of conversations from the AF networking issues. So this is definitely one of those. This is the solution eventually. If you set completion block, so completion block, again, this thing on NS operation, I'm overriding that in the subclass, and what I'm doing is I have a block reference to block self, and then I have that. After the whole thing finishes, I set completion block to nil, so we don't actually have that deallocation problem. Any reference to like the view controller or strongly capturing self, like you have a view controller that's making a request and it ends, any of those references will be nilled out whenever you set that completion block. So that was eventually the solution we came upon. Cool stuff. Another one was API consistency, which is a really important thing, and a thing that was kind of difficult for AF networking because it supports JSON and image requests, XML, pretty much anything you can make. How do you unify that? How do you make sense of those callback signatures in those blocks? It was a problem that I struggled with for a long time. And this Evan Long guy came along. I don't think that's his face. I'm not sure who that is. But yeah, he was kind of petitioning for more reasonable, more consistent formats for these completion blocks. So like whenever you get, it used to be that in some operations when you got success you had you know, an HTTP response. You could say it was a 200 or a 404, and then it would have actually the data that came with it. But he wanted to access more stuff with that, and we were trying to come up with a solution for that. Eventually what we came up with was the method signature for HTTP client, which actually refers to the request operation itself, where you're setting a completion block with success. And success, you have the operation itself, because the operation has everything that ever happened in the operation. So the request, response, and all the data. And then the response object, so JSON, image, etc. That's just for convenience. And then failure, that gives you the operation as well, and then an NS error. So having these consistent things allowed me to have the interface for HTTP client where you're enqueuing some sort of request operation. We don't know what it's going to return, but we do know that we can actually deal with it in a uniform way once it comes back. So uniform API design is important because, again, eliminating complexity, lowering entropy, it's all part of the same thread. And this last slide is sort of a feel-good one. It's the more you put in, the more you get out of it. And I have to say that I feel extremely fortunate for having the opportunity to work on AF networking and how much I've learned. And you know, I'm so happy to share because the more I share with the project, the more I learn from you guys. So thanks to anybody. Like, how many of you guys have ever opened up an issue on AF networking? Cool. Well, thank you. Or on Stack Overflow or anything like that, or any other project. I'm sure any open source project that you guys work on, whether it's opening issues or actually authoring and maintaining, you guys are doing great work, and you know, thanks. So, kind of 3 takeaway rules. Those were lessons. That was the descriptive stuff. This is the prescriptive stuff. If you're going to do this, 3 things: be present, be nice, and be Socratic. So, be there for your project. When people open up issues, be responsive to them, because they are people and they have real problems, and you want to help them out because we've all been there, right? Be nice. We're all, again, humans. Let's remember this. It isn't just you know, text on a screen. And be Socratic. That's the most important thing, I think, is that, I don't know, when you do things for a while and you think you've seen everything, it's important to catch yourself. Whenever you feel like you're going to dismiss an idea, be like Socrates. Just ask questions, because that's really the only way you're going to get to the real truth there. And it's never too, I don't know, it's never too early to kind of make the assumption that you really don't know what's going on. Just keep humble like that. It works in the long run. So yeah, those are the 3 rules I had for you, and thanks.